All right, this is one of the AP Calculus free response questions on the exam. There are 7 different types. This is one of them. 6 of them come up every year, and that's half of your test grade. So you want to be good at each type of them. This is what I think of as analyzing graphs of derivative functions. Here it says the graph of f. That's not a derivative function. Sometimes it'll say graph of f prime or something like that. In this case, it says graph of f, and that's not a derivative, but you see later on that g of x is the integral of f. So f is actually the derivative of g of x. So we'll be looking at how to do these. The first thing to notice is that it says in part A, find g of 3. When we're finding g of 3, we just need to plug in 3 to g. So a, g of 3, is the same as g of 3 equals the integral from -3, instead of to x, we're plugging in 3 for x, of f of t dt. You always want to make sure you label things well. And so g of t is this integral. The integral from -3 to 3 of f of t, here's the graph of f. This integral is just the area from x equals -3 to 3. So the first thing is we need to find this area. And that's this right here. We've got a triangle here. And then down here we've got some negative area. This triangle we can find the area by doing the base times the height divided by 2. The base is 1, 2, 3, 4, 5. The height is 1, 2, 3, 4. We divide it by 2. So the area of this triangle is 10. Here, this area is below the x-axis, so when we do the integral, this will be negative, have a negative value. This is also a triangle. The base is obviously 1. The height, it's hard to tell exactly what this is. It looks like 2, but you want to make certain by finding the slope of the line. This line has a slope of, let's see, it goes down by 4 over by 2. So the slope is -2. So if we went over by 1, it went down by 2. So this has a base of 1 and a height of 2. So 2 times 1 divided by 2 is 1. This area is 1. And so g of 3 is 10 minus 1, which is 9. That's the integral from -3 to 3 of f of t. All right, the next question, B. It asks where g of x is increasing and concave down. This is taking stuff from the first semester and mixing it with the stuff from the second semester. So g is increasing, which means that g prime has to be greater than 0. G is concave down, which means that g prime prime needs to be less than 0. So we should know that from the first semester. So we don't have a graph of g. We have this equation for g. G prime is the derivative of this integral. And the second fundamental theorem of calculus says that if we do the derivative of an integral, g prime of x will equal the derivative of this integral, which is just, we plug in the x into here. And if we had needed to, we would have multiplied by the derivative of x, but the derivative of x is just 1. So the derivative of g is f of x. That was, that's what I mean by saying it was a derivative graph. This graph is actually the derivative of g, which is what it's asking about. So g is increasing when f of x is greater than 0, because that's the derivative of g. F of x is greater than 0 between -5 and 2. And g prime prime, we need to find the second derivative of g. So the second derivative of g is the derivative of the first derivative. The first derivative is f of x, so the second derivative of g is f prime of x. And we want for that to be less than 0. So what it means for f prime to be less than 0 is the slope of this graph needs to be less than 0, slopes of the tangent lines, and that happens between x is -5 to -3. That's where f is decreasing, so f prime is negative. And then also between 0 and 4. And we need both of these things to be happening. So f is above 0 on this interval, and f is decreasing here and here. So the places it's both happening is between -5 and -3, and between 0 and 2. So our answer is G is increasing and concave down on the interval from -5 to -3 union 0, 2 because f, which is G prime, is positive and decreasing on this interval. When you do this, your answer always needs to be about the graph. So the graph of f is positive, the graph of f is decreasing, and that's how we knew about G. They don't tell you anything about G except from what you know from f. So you have to answer for f. All right. They've been doing this more in recent years where they give you another function and you have to analyze that. So h of x is g of x over 5x, and what's h prime of 3? Well, this is quotient rule. The quotient rule says you do the derivative of the top times the bottom minus, leave the top alone, times the derivative of the bottom all over the bottom squared, and it wants you to find h prime of 3. So it's g prime of 3 times 5 times 3 is 15 minus g of 3 times 5 all over 15 squared. Again, we have to do g prime of 3. G prime of 3. Remember that the derivative of g of x is f of x. So it's f of 3. F of 3 just means you look at the graph and see what is the y value when x is 3. And the y value is -2. We also need g of 3. G of 3 is the integral from -3 to 3 of f of t. And you'll remember we actually found that in A. Part A, we said this was equal to 9. And so h prime of 3 is equal to -2 times 15 minus 9 times 5 over 15 squared. This is a no calculator section, so simplify as little as you feel comfortable with. I feel comfortable saying -30 minus 45. I'm not going to simplify 15 squared. I'm just going to leave it as -70 divided by 15 squared. Okay. You could simplify it more if you'd like to, but you don't need to because it's a free response. So this is a fine answer. We need to make sure we've labeled this. This is h prime of 3. Okay. All right, the last part, the function p, here's another function. P of x is f of x squared minus 2. Find the slope of the tangent line to the graph of p, so p prime, at the point where x is -1. So we need to find p prime of -1. That's the slope of the tangent line. So p prime is going to be the derivative of this. So p prime of x equals, the derivative of this is going to be chain rule, f prime of x squared minus x times the derivative of the inside, which is 2x minus 1. We can now plug in -1. F prime of -1 times -1 is 1, minus -1 times 2 times -1 minus 1. So this is f prime of 2 minus a negative is a positive times -2 minus 1 is -3. So all we have to do is f prime of 2. F prime of 2, here's the graph of f, means the slope of the graph at x equals 2. And the slope of the graph is just the slope of this line. So f prime of 2 is -2. We already found the slope of the graph, times -3 equals 6. That is p prime of -1. So that is this one. There is always in these problems something where you have to do an integral. There is always in these problems somewhere where you have to talk about the derivative of this function, which is basically just asking about the derivative, this graph. So they usually ask about both the values of this graph, which we saw, and the derivative of this graph, which we saw in a few different places. Hopefully this was helpful.